Welcome to tonight's Kent Planning Network for Nature webinar. My name is Emma Waller and I'm Kent Wildlife Trust's Planning and Policy Officer. So I'm here tonight to talk all things bats. In case people aren't familiar with the species, I'll be giving a brief introduction to our British bat species and what key considerations must be taken into account to protect bat populations in regards to planning and policy. So hopefully this will be insightful for when you're next reading a planning application for a development that you're concerned about. I'm hoping the information within this webinar will be useful for you to be able to assess whether you think policy and best practice guidelines are being followed. So just a quick introduction of myself. My name is Emma, and before I started working at Kent Wildlife Trust, I worked as an ecologist for several years. I have a particular interest in bats and hold my own bat licence. And I've been extremely lucky enough to work with a lot of our British species, including radio tracking two of our rarest species, the Barbastelle and Beckstein's bat. And my master's dissertation was also looking into long-term population trends of hibernating greater horseshoes. And I'm also a volunteer bat rehabilitator for Sussex Bat Group, who, like Kent Bat Group, both do incredible, amazing work advocating for bats. So before I get started, I just have some quick housekeeping to run through. You may have already noticed that you're not able to turn on your video or microphone, but you can ask questions using the Q&A box at the bottom of your screen. So please do use that if you have any questions. Just pop them in the box at any time during the webinar, and we'll see if we can get through some of these at the end. So the presentation is also being recorded and will be available on the Kent Planning Network for Nature forum. So please share the video once it's been uploaded and feel free to rewatch at any time. So let's get started. So just a brief background on why bats are such incredible animals. So there are over 1,400 species of bats making up around 20% of all mammal species worldwide, which is a huge proportion of our mammals. Species of bats are divided into two suborders. We have the larger fruit-eating megabats and the smaller, often insectivorous microbats, which include all the bat species found here in the UK. As these suborders suggest, bats vary in sizes. For example, certain species of fruit bat can have a 5-foot wingspan and weigh over 1.5 kilograms, whilst others, such as the bumblebee bat, is much bigger than 1.5 inches and weighs no more than 2 grams. Bats are also the only true flying mammal in the world, and they are extremely important to the ecosystem. For example, insectivorous species are natural pest controllers. One pipistrelle, for example, can consume up to 3,000 mosquitoes in one night, whilst fruit bats are important pollinators and seed dispersers. Without the long-nosed bat, for example, we wouldn't have tequila, as they are almost the sole pollinator of the agave plant. So next time you're drinking a margarita, give a little cheers to the bats that made that possible. So as you're probably aware, bats use echolocation to navigate and hunt in the dark. So they emit these high frequency sound waves, which are usually too high for humans to hear, which is why we use bat detectors during surveys to record and identify species of bats. Saying that, you do sometimes hear social calls without a bat detector, which are a lower, louder frequency. And then even nocturals can sometimes be heard faintly foraging, which sound like these kind of high frequency kind of sound waves. But the majority of the time, these sound waves are emitted at frequencies above the human hearing range. And despite the popular saying, blind as a bat, bats are not actually blind and they can see just as well as humans. but because they are nocturnal, they have evolved to use this echolocation to help navigate and hunt in the dark. So each bat species has a different echolocation, which means we can identify species based on what the call sounds and looks like. So on this slide, I've given 3 different examples of British bat calls, showing how varied they can be. So whilst these 3 examples look very different from one another and can be easily ID'd from one another, you may notice when reading bat reports, if you're looking at a planning application, that bats from the Myotis genus are not always identified to species level, as they are the hardest to separate into species when analysing their calls due to overlapping of call characteristics, such as the frequency, sound and appearance of the calls, which does make it quite hard to confidently identify Myotis species to a species level. So when this isn't possible, you will often see in bat reports that they refer to them as just Myotis species. And then just so you can hear how different bats calls, how different bat calls sound depending on the species, I'm hoping these recordings will work, so apologies if you can't hear them, but we'll give it a go. So first, I think it's going to be the common pipistrelle, which sounds like irregular kind of smacks. So I'm really hoping you can hear that. Next, we have my personal favourite, the greater horseshoe, which kind of reminds me of kind of these miniature spaceships. I love that sound. And then next we have the brown long-eared bat, which echolocate relatively quietly and are often described as sounding like bubbles when you blow down into a straw of liquid. So I really hope you heard those calls there. So in Britain, we have 18 species of bat, 17 of which are confirmed as breeding. However, in the UK, we are seeing increasing numbers of vagrant species that occasionally make an appearance in the UK. These are usually blown over from mainland Europe. But in Britain, our resident 18 species make almost a quarter of our mammal species. So most common species of bat include the common and soprano pipistrelle. So they may be our smallest species, weighing up to 5 grams. But as previously mentioned, a single pipistrelle can eat up to 3,000 small insects in a single night. So this shows just how important and vital they are as a natural pest control. So the common and soprano pipistrelle were only separated as separate species in the 1990s, and up until then they were thought to be the same species of bat. So the main physical difference to tell them apart is that common pipistrelle have darker faces compared to sopranos, which tend to be a little bit paler, but their main difference is their echolocation. So common pipistrelle echolocate at a frequency of around 45 kilohertz, compared to sopranos, which are around 55 kilohertz. So if you're reading a bat report in a plan application and they refer to some species as a P45 or a P55, then these are the species that they are talking about. They're talking about the common and the soprano pipistrelle. So both species typically emerge from their roosts around 20 minutes after sunset and can be often found foraging in gardens. In terms of roost sites, they're often found roosting under hanging tiles, roof tiles, barge boards, gable soffits, as well as cracks in trees and under lifted bark. And then there is also a third species of pipistrelle that we have here in the UK, and this is the Nethusius pipistrelle. And this is a relatively newly confirmed breeding species and is relatively under-recorded here in the UK. Up until 1997, they were considered as a vagrant species, but now we do know of several breeding roosts across England. So the Nethusius pipistrelle is also a migratory species, often making long journeys across Europe. A few years ago in Kent, two Nethusius pipistrelles, which were ringed in Lithuania, were then found in Ore and Stodmarsh. And in 2022, an enthusiast pipistrelle set a new bat migratory record, where a single individual ringed in Russia was then discovered in the French Alps, traveling over 2,400 kilometers, which is crazy when you think of how small they are. So as you can see from this photo showing all three pipistrelle species, the main difference between the three is that the enthusiast pipistrelle are larger and they echolocate at around 37 kilohertz. Next, we have two long-eared species. We have the brown long-eared and the grey long-eared bat. So the brown long-eared bat is another very common species we have in the UK, found throughout Britain, compared to the grey long-eared, which is one of our rarest species of bat, found only in southern England in relatively small numbers. So long-eared bats are light sensitive and typically emerge around 40 minutes after sunset. So their roost sites are usually near woodland as they forage along linear features such as woodland edges and hedgerows. And compared to pipistrelles, long-eared bats like a bit more space for their roost sites. So they're often found roosting in high timbered lofts where they can fly around the roof void before emerging. So in the UK, we have 7 myotis species. We've got Daubenton's, Natterer's, Brandt's and Whiskered, which are the more common of the 7 species. So Daubenton's bat can be easily ID'd by their feet. They have these amazing big feet, which they use to catch insects right off the water's surface. And they also use their tail to swoop up insects into their mouths. So as you can imagine, they roost near water, with maternity roosts often found in underground sites, such as culverts. The Natterer's bat looks fairly similar to Daubenton's, however, typically have paler fur and broader wings, which enables them to fly slowly, where they actually catch spiders right out of the webs. Roost sites have been identified in old stone buildings, such as castle, manor houses and churches, or large timbered barns where they roost in crevices and gaps in beam joints. And like all myotis species, they are light sensitive and emerge about an hour, give or take, after sunset. So whiskered bats can be ID'd by their very dark faces and ears with a dark chestnut brown fur. They can sometimes be confused with common pipistrelle, but like all myotis species, they are larger than common and soprano pipistrelle. The whiskered bat is a crevice-dwelling species, often found roosting kind of in all types of buildings, modern and old, and typically emerge 30 to 40 minutes after sunset. And then the Brandt's bat looks very similar to the whiskered bat. However, they have slightly paler fur. They were thought to be the same species in the UK up until the 1970s, and their key ID feature to tell them apart is actually to look at their teeth, as their premolars are different sizes. Brandt's bats are often found in buildings and have a similar emergence time to whiskered bats, around the 30 to 40 minute mark after sunset. So the last 3 myotis species are probably some of our rarest species we have in the UK. So the first is the Bechstein's bat, which is only found in South East Wales and parts of southern England. So in 2019, I was extremely lucky to help discover the second only known maternity roost in Kent, which might now sadly be the only maternity roost in Kent, as the first one, discovered in 2012, was sadly accidentally destroyed during some tree clearing works by the landowner. They are a woodland specialist, where they roost, forage and also hibernate in mature, dense, deciduous woodlands. And as they are one of the UK's rarest mammals, there is still a lot we don't know about them. And so we're still learning a lot about them. Then we have the Alcatoe bat, which is a relatively new species to the UK, first recorded in 2009 in Sussex, and then again in Yorkshire, but its distribution across Britain is currently unknown. We know very little about this species, apart that they are a woodland specialist, foraging in dense deciduous woodland. And then the last motor species is the greater mouse-eared bat. Now, this bat is so rare that up until 2022, we thought there was only one individual left in the UK. They were declared extinct in Britain in the early 1990s. However, since 2002, the same single individual male, who has been lovingly named as Lonely Joe, has been found hibernating in a tunnel in Sussex. As far as we know, we have no idea where he goes in spring or summer, but almost every year since 2002, he has been found during hibernation surveys. We do know it's the same individual, as he was ringed with a unique identification number. So it was believed that he was potentially the last individual in the UK, which was obviously extremely sad. However, in 2022, in the same tunnel, volunteers at Sussex Bat Group were very surprised to find not one, but two new greater mouse-eared bats. And in 2023, another greater mouse-eared bat was found during hibernation checks in a different tunnel in Sussex. So it's uncertain where these new individuals have come from, but it's thought that it's most likely they have come over from mainland Europe rather than breeding here in the UK. But fingers crossed, one day again, hopefully they will breed here, as their numbers seem to be increasing. So next we have our three largest species of bats. We've got the nocturnal Lysa's bat and the serotine. So the greater mouse-eared is technically the UK's largest species, but because there's so few of them, people often refer to the nocturnal as being the UK's largest species of bat, weighing up to 30 grams with a wingspan between 30 and 40 centimetres. They are a high-flying species, foraging at or above tree canopy level, and often emerge from their roosts before or at sunset. So they look very similar to Lysa's bat, but their main difference is the size of their forearms, of nocturals being larger, and that the noctural has shorter velvet-like fur compared to Lysa's bat, which has longer, thicker fur. Lysa's bat can also be found roosting in both trees and buildings, compared to nocturals, which roost almost exclusively in trees, often found in woodpecker holes. And then next we have serotines, which are another one of our larger bat species. They have large broad wings, and often hunt beetles sweep them off the ground, found largely in southern England and Wales. And serotines are often found in buildings with high gables and cavity walls, and they're actually very rarely found in trees. So they emerge from their roosts approximately 20 minutes after sunset and typically forage in good light. So next we have the barbastelle, which again is one of our rarest species of bat, found in southern and central England and Wales in relatively small numbers. So they look very unique, often described as having a pug-like face. They are extremely fast flyers, often flying well over 30 kilometres from their roost site to their foraging site. And there has yet to be a confirmed barbastelle roost in Kent. Individuals have been recorded in Kent during bat surveys close to the Sussex and Essex borders, where they are known to be, but no one has yet to identify, as far as I'm aware, of a physical roost in Kent. So if you're reading a planning application and this species is mentioned within an ecological report for development in Kent, then it's definitely worth flagging. And then last but not least, we have probably my two favourite species. We have the greater and lesser horseshoe bats. So both look very similar. However, the lesser horseshoe is actually one of our smallest species, not much larger than a common pipistrelle, compared to the greater horseshoe, which is often described as being of the size and shape of a pear. Horseshoe bats are named after their nose leaf, which is a circular flap of skin around the nostrils. So most bats actually emit their echolocation through their mouths. However, horseshoes emit theirs through their nose. Therefore, it's thought that the nose leaf focuses and directs their echolocation, much like a satellite dish, which helps them pinpoint their prey. So both species are rare, found in southwest England and southern Wales. However, you might have recently heard within the last few years that a greater horseshoe maternity roost has recently been discovered in West Sussex. And both species have actually been recorded for the first time in over 100 years in Kent, where they have been found during hibernation surveys. And then these are just some of our vagrant species, which do occasionally show up in the UK, usually along the coastlines. However, these species do not breed here in Britain, and sometimes come over just for hibernation or are accidentally blown over from France. So what does a bat get up to in a year? Well, they start the year in hibernation, where they require high humidity and stable temperatures. So places like underground tunnels, basements, mines and dene holes all make really good hibernation sites, but they also can be found hibernating in trees and buildings. Ironically, our most common species, the common and soprano pipistrelle, are species we actually see the least during hibernation surveys. So pipistrelles are rarely found hibernating in underground sites, but studies in the Netherlands have found large numbers of pipistrelles hibernating in cavity walls of tall buildings, such as tower blocks and flats. So it's thought that they likely hibernate in similar structures here in the UK. So bats do come out of hibernation during the winter to either move location depending on temperatures and humidity. And studies on greater horseshoes also show that they do come out of hibernation to forage when there is a mild ambient temperature of 10 degrees or above. And then depending on temperatures and weather patterns, bats begin to come out of hibernation in March time, and by April should be fully active. And by this point, they'll be very hungry, so we'll be restoring their fat reserves with lots of feeding. So May is when females will begin to form maternity roosts, which they are extremely loyal to and will often use the same maternity roost each year. So depending on species, maternity colonies can vary in size. Soprano pipistrelle, for example, often have large maternity colonies, some containing over 1,000 individuals, compared to other species such as nocturals, which can consist of just several females. By June, females will have given birth to a single pup, with on the very, very rare occasion two, but usually just the one. And when pups are born, they are already a third of the weight of the mother. So that's the equivalent of a human giving birth to a 3-year-old. So respect to female bats. So when pups are first born, the mothers will actually fly with the pups clinging to their bellies. But within a few days, they quickly become too heavy, and the females will leave them in their roost. And like all mammals, bats produce milk to feed their young, so the females will come back to the roost throughout the night to feed them. So baby bats develop quickly and will usually actually begin to learn how to fly at around 3 weeks old, which is often when we get lots of call-outs to rescue young bats found grounded on the floor, likely grounding themselves as they take their first flight. And by 6 weeks, they should be fully independent and foraging by themselves. And by late August, the maternity roosts will start to break up and females will begin to disperse. So for my master's dissertation, I was analysing over 30 years of greater horseshoe hibernation data. And one thing that I did notice was the high proportion of post-lactating females, so females that had given birth that year, with juveniles that had been born that year. So it's thought that maybe in certain species, at least, that the juveniles do actually stick with their mothers right up to hibernation, possibly for the benefit for the mothers showing their young where to hibernate, as like maternity roosts, hibernation sites are extremely important, and bats are very loyal to these sites. Take Lonely Joe, for example. He's obviously been found hibernating in the same tunnel each year since 2002, which is incredible, and also highlights that bats do have long lifespans. I think the record for a wild bat was a Brandt's bat, which was originally ringed in 1964 in Russia, and was then recaptured in 2005 wearing the same ring, making it at least 41 years old. And we know from hibernation data that greater horseshoes also live to around the 30 plus year mark. So that's just incredible. So bats don't waste any time, and once their maternity roosts have dispersed, mating season begins. Often when undertaking bat surveys in late summer, early autumn, you can hear a lot of social calls, which sound like these clicks and buzzes, and that's the males trying to attract the females. You do actually often see bats chasing each other whilst using these social calls. So on survey, we used to refer to it as the bats playing kiss chase. And then you get mating roosts, which is usually protected by a single male, which they are territorial over and will kind of chase away other males. So in October, you get a lot of swarming behaviour at hibernation sites, where there could be hundreds or even thousands of bats swarming at the entrance of a cave or a mine or wherever the hibernation roost is. So no one is 100% sure why bats do this, but the most accepted theory is that bats from numerous different colonies from quite a wide ranged area come to this location to mate, as it enables a diverse gene flow. So once bats have mated in autumn, the females will then delay fertilization of the egg until spring, after they've come out of hibernation. And then depending on species, the pregnancy lasts between 6 or 9 weeks. And then by November, temperatures will have dropped and bats will have begun to go into torpor, which differs from full hibernation, as torpor is involuntary and lasts for shorter periods of time, for example, a few hours or a day or two. And then by December, bats will have gone into full hibernation, and then the cycle starts all over again. So why are bats under threat? So unfortunately, bats in the UK are facing numerous threats. So all species of bat in the UK rely heavily on linear features such as hedgerows, tree lines and woodland edges to commute through the landscape. And over the past 100 years, these habitats have been lost and destroyed for the increase of urbanisation and intensive agriculture, resulting in the loss of foraging, commuting and roosting sites. Studies also showing that climate change is having an impact on British bat species, with changes in temperatures and weather patterns altering insect availability. This year, 2024, has been one of the worst years for insects in a long time. Climate change is also altering hibernation cycles and also breeding success. And also the use of pesticides, increase in light pollution, and even wind turbines are also thought to be having a negative impact on bat populations. So these threats make conservation efforts and effective policy implementation crucial for bat survival. So in the UK, all bat species and their roosts are protected by law. The Wildlife and Countryside Act 1981 and the Conservation of Habitats and Species Regulations 2017 make it illegal to deliberately capture, injure or kill a bat, damage or destroy a bat roost, even if bats are not present at the time, disturb bats, particularly in ways that might impair their ability to survive, breed or hibernate. So these laws ensure that bats are considered in planning and development, and that any activities potentially affecting them are subject to strict assessments by local planning authorities and also by Natural England, who are the government's advisory body for the natural environment. We also have 4 bat species which are listed under Annex 2 of the Habitat Regulations, which lists animals and plants whose conservation requires the designation of special areas of conservation, also known as SACs. So these species are the greater and lesser horseshoes, and also the barbastelle and Bechstein bat. So in terms of planning requirements, before a planning application is submitted, the applicant will need to look into any potential impacts the development will have on the environment, whether that's for a new housing development, road scheme, or an extension to a house or barn conversion. So the applicant will need to hire an ecological consultancy to assess these potential impacts and provide advice on how to avoid, mitigate, and as a last resort, compensate, should permission be granted. So failure to address such issues can result in planning applications being refused, and local planning authorities will only accept ecological documents provided by licensed ecological surveyors who can provide detailed professional information. So the first ecological survey to be carried out is usually a preliminary ecological appraisal, also referred to as a PEA. So this is a site walkover and includes a phase 1 habitat survey, which provides information relating to the habitats on site, and also a protected species assessment, which identifies potential for protected species. So a preliminary roost assessment is often undertaken at this stage, which involves an inspection of all buildings and trees within the application site to identify potential roost features, such as woodpecker holes, lifted bark on trees, or gaps under hanging and roof tiles, or gaps at the eaves, gable ends, or soffit boxes. So an internal inspection of any roof voids is also usually undertaken, searching for evidence such as droppings or bats themselves. So this survey must be conducted by a qualified licensed ecologist, as there are risks of encountering and disturbing a bat roost. So if bat droppings are found, then these can also be collected and sent off for DNA analysis to identify species. So if suitable roosting features or evidence of bats are identified, then further surveys will be needed. So these are usually emergence or sometimes re-entry surveys, where ecologists will observe and record numbers and species of bats either emerging or re-entering a roost. And then for larger scale developments, activity surveys may also be required, which usually involves walking a transect of the application site, recording the flight and foraging behaviours of bats. And then sometimes static bat recorders are also left out for several nights to help get a broader understanding of number of species used in the site. So this data would then help design sensitive lighting strategies to ensure that favoured foraging or commuting paths are not directly impacted by either an increase in artificial light or by habitat loss. And then if a site has potential to support hibernating bats, hibernation surveys over winter would need to be carried out, as hibernation roosts are also legally protected. So when looking at a planning application, it's really important to see whether the protected species surveys are following best practice guidelines. So in regards to bats, ecologists should be following the Bat Conservation Trust's Bat Survey for Professional Ecologists and Good Practice Guidelines, 4th edition, which was published in 2023. So these guidelines include timings and methodologies of surveys, how many surveys should be undertaken, and equipment needed, such as night vision or thermal cameras. So, for example, bat surveys should be spaced across the whole bat activity season, which is between April and October, with a minimum of 3 weeks between each survey, with at least one survey undertaken within the core bat maternity season, which is mid-June to mid-July, to identify any maternity roosts that may be present. It's also worth mentioning that these are guidelines, and even though they should be followed, it is balanced between the judgment and evidence provided by the ecologists. So if guidelines aren't being followed, then a justification may be required by the ecologists as why they're not following these guidelines. So what happens if a bat roost is present? So if a development, no matter how small or large, will impact a bat roost, then a mitigation licence will be required. So in England, protected species licences are obtained by Natural England. Wales and Scotland have different environmental bodies, but the purpose is all the same. So the mitigation licence allows the applicant to undertake works that would otherwise be deemed illegal. It's also worth mentioning that a mitigation licence can only be obtained once planning permission has been granted and once all relevant ecological planning conditions have been discharged by the local planning authority. So in England, we have 2 bat mitigation licences. We have the low impact class licence, which can be obtained if a development is impacting only low numbers of the more common species. And then we have the full mitigation licence, which is used for either our rarer bat species, or if a development is impacting a maternity or hibernation roost, or any roost within a triple SI or SAC. Tree roosts are also not covered by the low impact class licence, so tree roosts will need to be covered by the full bat mitigation licence. So when the licence has been granted by Natural England, there will be conditions to the licence that the applicant must follow. So failure to comply with the conditions set out in the licence is a criminal act, and penalties for non-compliance or carrying out licensable activity without the licence are potentially severe, with prison time or unlimited fines. And the responsibility of following the conditions of the licence is that of the applicant. So to be able to obtain a bat mitigation licence from Natural England, the applicant must first convey how they are providing mitigation, compensation and enhancement measures. So firstly, the applicant must show how they are preventing or minimising the worst impacts through mitigation. So this can include timings. For example, if the proposal is for a new roof and a maternity roost has been identified, then you would need to avoid undertaking the works during the maternity season by either removing the roof in early spring before bats arrive, or in early autumn after the maternity season is over. So the applicant can also reduce impacts through careful design, such as incorporating sensitive lighting, to leave dark corridors, or by only using downward facing lighting. And then when it comes to starting the works, a suitably experienced and licensed ecologist should be on site, supervising the roof strip or tree removal or whatever the works are. And this is called Ecological Clerk of Works, also known as ECAL, and ensures that people who are undertaking the roof strip or tree removal are aware that bats might be present, and so are doing it carefully. And if a bat is found, then the ECAL will examine it for signs of injury and then carefully move out of the works area and placed in a bat box or other compensation measures required as part of the conditions of the licence. So compensation and mitigation are two very different things. So as previously mentioned, mitigation helps to reduce negative impacts, whilst compensation makes up for the loss of a bat roost through the provision of a replacement roost. So you'll probably see more often than not that the most frequent form of compensation is in the form of installing tree-mounted bat boxes. I'm not saying this is poor compensation, but it is often the cheapest and easiest, and therefore not always the best or most suitable. So compensation measures should be like for like. Therefore, if you are losing a bat roost in a roof space, you can't put up bat boxes in trees. The applicant would need to replace that roof space, which is often done through the creation of a bat loft or bat barn. Other roost prevention measures, provision measures, can include bat roof and ridge tiles or integrated bat tubes. Basically, if you're going to lose a bat roost, you need to put it back one way or another on a like-for-like basis. So next we have enhancements. And so the main difference between enhancement measures and mitigation and compensation is that enhancement provides an improvement for the ecology and biodiversity of a site. Mitigation and compensation do not go beyond reducing impacts and replacing what has been lost. So policies and legislation have now been put in place which requires developers to improve the biodiversity condition of the site and put back more than what has been lost. For example, if you are losing one bat roost, you might provide provisions for multiple roost sites via a variation in roosting opportunities, such as placing bat boxes in trees, as well as bat tiles, bat tubes, and a bat loft. If it's a large housing development on agricultural land, for example, then providing important foraging and commuting habitats, such as the creation of ponds and wetlands, planting hedgerows or woodlands will also enhance the site for bats. And then once the development has been completed, post-construction monitoring surveys will also be carried out to ensure that mitigation and compensation measures are effective and bats are not adversely impacted by the development. So what can you do to help bats? So there are numerous ways in which you can positively impact your local bat population. So if you're here today, I assume you might be a member of Kent Planning Network for Nature. And if not, I really recommend you join. It's completely free and easy to sign up to. The purpose of the network is to help encourage positive engagement through the planning system to ensure that developments take accountability for the protection and enhancement of Kent's biodiversity. So once the plan application has been submitted, you will have a period of time, which is usually 21 days, where there will be a public consultation, giving the public an opportunity to review the planning application and provide comments. So on the Kent Planning Network for Nature forum, Kent Wildlife Trust have uploaded a guidance document on how to respond to a planning application. And hopefully this provides some useful information on how to write an effective consultation response to help give nature a voice through the planning system. As well as engaging within the planning process, you can also take measures at home to create a bat-friendly garden. You can do this by installing a bat box, which can either be bought off the internet, or I've actually recently seen them being sold in garden centres. You can also build your own bat box. So the box should be at least 3 metres high, ideally installed either on a mature tree or under the eaves of the eastern or southern elevation of a building. Bats are a protected species, which means if you do install a box, sadly, you can't check to see if the box is being occupied by bats, as disturbing a bat roost is a criminal offence. So once the box is in place, you should really leave it there and not move it again. But if for whatever reason you do need to move it, then I recommend you get in touch with your local back group, such as Kent Back Group if you live in Kent, who will be able to provide advice or have someone with a license come round to check it before it's taken down. You can also attract insects to your garden by planting a wide range of plants that flower throughout the year. And like all animals, bats need to drink. So installing a wildlife pond is another great way to not only benefit bats, but obviously other numerous wildlife. And also reducing artificial light in your garden is also really important. So if you have security lights, then you can fit them with hoods to direct the light downwards, or you can also set them to a timer or have them come on only when triggered, which will help keep your garden dark. And obviously, if you do install any bat boxes, then these should be away from any direct artificial light. I also recommend visiting the Bat Conservation Trust website, where they have lots of useful information and resources, as well as supporting and joining your local bat group. There are over 80 bat groups in the UK made up of dedicated volunteers, and you don't need to be an ecologist or bat expert to join. If you just want to learn more or want to learn how to use a bat logger, volunteer on surveys, then please do contact your local bat group. Likewise, Kent Wildlife Trust put on regular talks and bat walks, and we've recently launched our Save Our Woodlands appeal to raise money to purchase at-risk woodlands to conserve biodiversity, which obviously in turn will help protect bats, as woodlands are such a vital habitat for them. So that's it for the webinar. Thank you so much for taking the time to join and listen to me for what feels like I've been talking for ages. So I really hope this webinar has provided some useful information, and hopefully you've learned something new and interesting about bats. If you are at all worried about the development and its impacts on bats or wildlife in general, then please do email either Kent Wildlife Trust and it'll be passed on to our planning and policy team, or my email is on this slide here if you want to note that down and email me directly. I'll be more than happy to answer any questions. So I think now I'm just going to answer some questions that have been asked whilst I've been talking. So let's jump in, see what we can get through in the next 5 or 10 minutes. And if I don't answer your questions, please do use the Kent Planning Network for Nature forum to ask any questions that I haven't managed to answer, or feel free to contact me by email. So I'm just going to stop share.